Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2017, paper 2, higher tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. Circle the fraction that is equivalent to 3.875. Now this is the calculator paper, so probably the easiest thing to do is to tap each one into your calculator one after the other and then use a symbolic to decimal button to convert it into a decimal. You should pretty much easily find that that's 31/8. Question 2. What is 50 as a percentage of 20? So if you get 50 out of 20, I love maths, everything is possible, and times it by 100, you'll get 250%. Question 3. Circle the point that does not lie on the curve y equals x cubed. Okay, so to work these out, all you got to do is put both parts of the number in and see if it's true. So circle the point that does not lie on the line. Okay, so the y coordinate has to be a cube of the x coordinate for it to be on the line. So that one is all right. 5 and 125. 5 cubed is 125. And if I take minus 1 and I times it by itself 3 times, I'm going to get minus 1. So that one's good. Negative a half cubed, 2, 4, 8. That one looks all right. I think it must be this one. That's the one that doesn't lie on the line. Third cubed would be 1/27 and not 1/9. Question 4. Which one of these is a unit of density? Circle your answer. Now, hopefully you remember that density is equal to mass divided by volume. So density is a compound unit then, isn't it? So we're looking for units that are mass divided by volume. Now, if you have a look at this first one, I've got a mass, but I'm dividing it by m squared, which is an area. The second one is an area divided by a mass. That's no good. The third one is mass divided by m cubed, so a cubic meter. So that looks like volume, so that one's good. And finally, you've got volume divided by mass, which is the wrong way around. So it's kg/m cubed. Question 5. Solve for lots of 3x minus 2 is equal to 2x minus 5. Okay, so let's just write down what we've got to start with. Probably the easiest way is to multiply out the brackets. So 4 times 3x and 4 times minus 2, which will give me, funny weird pen, which gives me 12x minus 8. And then moving my 2x over here and my minus 8 to this side. So change sides, 12x If I move the 2x to the left, it's going to become minus 2x, 12x minus 2x. And I've got negative 5 already there, and if I move the negative 8 to the other side, it's going to become positive 8. So 12x minus 2x is 10x, and negative 5 plus 8 is 3. Give me x is 3 tenths, or 0.3. I'm just going to write down 3 tenths. Here's my answer. Question 6. The graph shows information about prisms with the same volume. So we've got a kind of a strange looking graph here with length on one axis and area of the cross section on the other. So as length increases, area of the cross section decreases, and vice versa. Give one example to show that the volume is 24 centimeters cubed. Okay, so let's just pick any value on here. So the volume of a prism is given by its cross section, sectional area, times its length. So we basically need to take a point on this curve, work out the two values and multiply them together, and that should give us the volume. So let's take this point here on the graph, because it's got nice easy points to read. So look, reading down from there, I can see that the area is 6, and reading across, the length is 4. So taking my area of 6 and my length of 4 and multiplying them together, you can see that does give 24 cubic centimeters. Right, so part B says the diagram shows a prism with volume 24 cubic centimeters. The height of the triangular cross section is h. Work out h. So I know that the length of this prism is 5. So using my graph, I can then work out what the cross-sectional area should be. So coming back up to the graph. So length of 5 is, let's just get my ruler out. Reading across from 5 to the graph. Just pick a different color. And then reading down. That gives me a cross-sectional area of 4.8 centimeters squared. So given that the cross-section is equal to 4.8 from the graph, then I know that the area of a triangle is going to be half base times height, and in this case the cross section is the area, so that's going to be a half times the baseline, which is 6, times the height of the triangle that I'm looking to find. So what can I do here? I can multiply these. A half of 6 is going to be 3, isn't it? So just simplifying that first, that's 3h is equal to 4.8, and then cross multiplying the 3 over there to find what h is. H is going to be 4.8 divided by 3, which is 1.6. So it's going to have a height of 1.6 centimeters. Question 7. Describe fully the single transformation that maps triangle A onto triangle B. Now B is an equal version of triangle A, so it's an enlargement with a fractional scale factor because it's got smaller rather than bigger. Now notice this question is worth 3 marks. We need to give 3 pieces of information in order to get all the marks for this question. Now the first mark you'll get from just writing down the type of transformation is, so just writing down the word enlargement will get us the first mark. The next 2 pieces of information I'm going to get is for the marks I'm going to get for the scale factor and for the center of enlargement. Now to work out the scale factor, you just need to find 2 similar sides, or 2 matching sides on your shape, and then divide one by the other. So if you look from here to here, it's 1, 2, 3, 4, 5, 6 squares, whereas this one is 2. So the scale factor then is going to be 2 divided by 6, or a third. So scale factor 1/3. And center of enlargement you can find using ray lines if it's not obvious. So find pairs of matching points on your object and image and draw a line through them. So there's one. There's my first ray line. Tops of the triangles. Tops of the triangles are here. Second ray line, and there's another one here. 2's normally enough, but let's just do 1 for luck. You'll find that they all kind of converge on one point, and that will be your center. So here, that's the center of enlargement there. So for the final mark, we just need to mention where the center is. So center, what's the coordinates of that? 5, 1. So enlargement scale factor 1/3, center 5, 1. 3 marks. Question 8. The table shows information about the distances walked by 120 students on their way to school in 1 week. And you can see that we've been given a grouped frequency table for those distances. So I've got 0 to 5. There are 20 students who walk between 0 and 5. 48 students walk between 5 and 10 miles. 30 students walk between 10 and 15 miles. And 22 walk between 15 and 20 miles. Now we're asked to work an estimate of the mean for this data. Now the problem is that this data has been grouped, so we don't have the precise values, but we're estimating. So we're going to use mid x as an estimate for each of these. So you find mid x by adding your two n values together and dividing by 2. So 0 plus 5 is 5, divided by 2 is 2.5. You're basically averaging out the two endpoints. 5 plus 10 is 15, divided by 2 is 7.5. 10 plus 15 is 25, divided by 2 is 12.5. And 15 plus 20 is 35, divided by 2, 17.5. Okay, once you've got the mid-x, then we can work out f times x. So grabbing the calculator, 20 times 2.5, that gives me 50. 48 times 7.5 is 360. 30 times 12.5, 375. And 22 times 17.5, give me 385. Oops. Okay, and then just need to add all those up to get a total. So 385 plus 375 plus 360 plus 50. That gives me a total of 1,170. 1170. So then my mean then, my estimated mean, is going to be my sigma fx divided by my sigma f. In other words, the sum of fx, which is this value here, 1170, divided by my sigma f, that's the sum of my frequencies, which is this value, 120. Okay, just type that into the calculator again, 1170 divided by 120. Is 9.75. Okay, so that's my answer, 9.75. Question 9, work out the size of angle x. So you've got a right angle triangle, and I've been given two sides and I want an angle, so it's clearly going to be trigonometry. Now you can remember which ratios you want to use, whatever way you like. I use SOHCAHTOA. It's just a handy way of remembering each of them. So what have I got here? Let's label up the sides. I've got my angle here. So this is the hypotenuse, it's the longest side. Relative to my marked angle, 3 is opposite and 7 is adjacent. So I've been given the opposite and I've been given the adjacent. So the ratio I want to be using then is going to be this one on the end here, tan. So then I'm going to write down what that ratio is. Tan of an angle is going to be my opposite over my adjacent. So subbing in from the diagram. So I haven't got theta, I've got x. So tan x equals, opposite is 3, adjacent is 7. So if I want to find x, I'm going to use the inverse tangent button on my calculator. So that's shift tan 3 divided by 7. So my calculator is saying 23 and change. I'm going to write that down to 1 decimal place. 23.2, and the unit is degrees, isn't it? 23.2. Question 10. Work out the next term in this quadratic sequence. Okay, let's start off by looking at the jump between the various numbers. So from 5 to 8 is 3. Difference between 8 and 14 is 6, and the difference between 14 and 23 is 9. So you can see that the common difference here for each of these is 3. It's going up in 3s each time, isn't it? So the next amount it's going to jump up with is going to be another 3. 9 plus 3 is 12, and 12 more than 23 is going to be 35. So the next term in this sequence is going to be 35. Question 11. Circle the expression that is equivalent to 3x squared divided by 6x squared plus 3. So can we cancel this down in any way, shape or form? Well, notice on the bottom you have two common factor. Well, you've got common factor of 3 there, right, haven't you? So you can factorize 3 out of both those terms. So that would give you 3 lots of 2x squared plus 1 on the bottom, factorizing out 3 of those two terms, and on the top I've got 3x squared. Now notice now that you've got two common factors top and bottom, 3 and 3, so I can get rid of those. That would leave me with x squared over 2x squared plus 1, which is this one here, look. Question 12. The table shows information about the UK and Germany. I've been given the population and area of both countries. Germany's got more people, but it's also got a bigger area. Population density is given as population divided by area. We're asked to compare the population densities of the UK and Germany. Okay, so let's work out what their population densities are first. So population density for the UK is going to be 64 million divided by 95,000. Okay, I'm just going to get rid of some of these zeros. Those 3 cancel out with those. So I've got 64,000 divided by 95. Just makes it a bit easier to type into the calculator. So 64,000 divided by 95 comes out to be 673 and change. So let's just round that off to 3 significant figures. Let's call that 674. I suppose that's people per per square mile, isn't it? 674 people per square mile. So population density of Germany is 82 million divided by 140,000. So again, I can cancel those zeros off. Just makes it a little easier to type in. So what does that give me? 82,000 divided by 140. Again, I'm just going to round that off to 3 significant figures. So that's going to be 586. So there's roughly 586 people living in every square kilometre of Germany. So you can see that the UK has a slightly higher population density than Germany then, doesn't it? So I need to compare these two. So I'm going to say that UK has a higher population density than Germany. Job done. Question 13. Two straight lines intersect at point P. Circle the coordinates of P. Okay, so I've been given the graph is y equals 3x. It's up here, look. Which means it's got a gradient of 3. That means for every 1 unit you go along, you're going to go 3 up. Now, I can work out from this bit here that the y coordinate of P is going to be -1. So it's going to be something -1, because it's on the y equals -1 line, which kind of rules out that one and that one. So is it -3(1) or is it -1/3 -1? So the gradient is y equals 3x. So for every 1 unit you go along, you go 3 up. So if I go 1 unit this way, I will go 3 down. So if I'm only 1 down, I can't have gone a whole unit then. It's got to be this one on the end here, -1/3 -1. So that when I take my -1/3 and I times it by 3, I'm going to get -1. So it's that one there, -1/3 -1. Question 14. A ball is thrown from a height of 15 meters. It bounces to a height of h1 and then h2 as shown. Okay, so here's my ball, it bounces and then bounces. Okay, so h1 is 3/4 of the original height. So h1 is going to be 3/4 of 15, which is 15 times 3/4. It's 11.25. Okay, and then Jack expects h2 to be 3/4 of h1. Work out the value of h2 that he expects. Okay, so then h2 then, if it's 3/4 of h1, we just worked out, let's write that a bit nicer, of h1, and we just worked out that that was 11.25. So what is 3/4 of that? So again, divide by 4 times by 3. That gives me 8.4375. Okay, so in fact h2 is 2/3 of h1. How does this affect the answer in part A? So rather than multiplying by 3/4 like we thought, we're now going to be instead multiplying by 2/3. Now, which is bigger, 3/4 or 2/3? Just from my knowledge of fraction, I know that this one is, the 3/4 is a bigger one. So I'm multiplying through by something that is slightly less than it was before. So if I'm multiplying through by a smaller fraction, then I think it's going to be lower than he expected. But anyway, I'm gonna work it out properly so we can compare our work anyway. So in fact h2 is 2/3 of h1. So we're going to work out what h2 is now, given that it's 2/3 of h1, which is 2/3 of 11.25, which is 11.25 divided by 3 times by 2, 7.5. So that is a little bit lower, because before we had it down as 8.4 and something, didn't we? So yeah, that is going down a bit. Okay, job done. Question 15. Mirek invests £6,000 at a compound interest rate of 1.5% per year. He wants to earn more than £1,000 in interest. Work out the least time in whole years that this will take. Okay, so with compound interest, we're going to be repeatedly multiplying through by a percentage of 1.5%. So my multiplier is going to be 100% plus my 1.5%, isn't it? which is 101.5%, which as a decimal is 1.015. Now I'm going to make use of a trick on the calculator to work this out. So after the first year, so in year 1, you're going to get £6,000 times by 1.015, which is equal to, well, if I just type that into my calculator, 6,000 times 1.015, I'm going to get 6090, but I'm going to do it slightly differently because I want to make use of the recursive features of the calculator by using the answer button. So if I'm just going to type in first off the number 6,000 and then press enter or equals, then 6,000 will be stored as the last calculated value. So then rather than writing 6,000 times 1.015, I'm going to write answer times 1.015, and you'll see it gives me the same answer of 6,090. So that's my value after year 1. Now the reason I'm going to do that is that now every time I press the equal sign, it's going to feed my last calculated value back into that function and then keep timesing it by 1.015. So if I press the equal button again, I get £6,181.35. So year 2 is 6181. I'm just going to round it off there, 6181. What am I trying to do? I'm trying to get more than £1,000 interest. So I'm going to have to keep going then until this amount goes over 7,000. So that's after 2 years. Year 3, if I press the equal button again, I'm getting 6274. Press it again. Year 4 is 6368. Press it again. Y5 equals 6464. Rounding up. Y6 6561. Year 7 6659. This is a bit boring. Year 8. Probably we don't have to write all these down. This is too long and bored. Year 9 6860. Year 10. We're getting close. Year 10 is 6963. So I think in year 11, yeah, that's when we go over, isn't it? 7067. So work out the least time in whole years that it will take. It will take at least 11 years. Okay, so it's taking him 11 years to get there. Question 16a, factorise fully 9y cubed minus 6y. Now notice the word fully, when they add that word in there, it means that there are more than one factor to find. So if you only pull out one factor, you won't get both marks. If you have a look at 9y cubed and 6y, you can see there are two factors that you can pull out. 9 and 6 are both multiples of 3. And y cubed and y both have a y in them, so I can take 3y out as a common factor of both those terms. 3y times 3y squared is going to give me 9y cubed, and 3y times 2 is going to give me 6y. So that's what I'm getting. That's what I'm going to get. 3y squared minus 2. 16b, factorise 3x squared minus 22x plus 7. Okay, so when you factorize a quadratic, it's going to go into double brackets like this. Looking at the first term, 3x squared, I can only really get 3x squared by multiplying 3x and x together. Note the minus and the plus. So my two numbers multiplied together are going to give me a positive value, and when I add them up I'm going to get a negative value. That can only happen if they are both negative. And then finally, looking at the number on the end there, that's 7. 7's prime, it's only got one factor pair, which is 1 and 7. So which way around do they go in? I can either put the 7 here and the 1 here, but that would give me, what would that give me? That would give me minus 3x minus 7x, give me minus 8x in the middle, which is not what I want. So it's got to be the other way around. Let's try it with the 1 here and the 7 here. Then my 3x times my minus 7 is going to give me minus 21, and minus 1 times 1 is going to give me another x, giving me minus 22x altogether. So that is the solution then, isn't it? So 3x minus 1, x minus 7 is the answer. Question 17. Work out the area of the parallelogram. Now, I've got the base of the parallelogram, which is 16 centimeters, but weirdly, I've been given the slant height rather than the height of this parallelogram. The formula that I know for parallelograms is area equals base times the perpendicular height, which is not what I've got here, so that's not going to work. What can I do instead? Well, I've been given an angle here, so well, I think I'm going to have to use some trigonometry, aren't I? Now I'm going to use a bit of a trick here. I'm going to take my ruler and I'm going to divide this parallelogram into two triangles, like so. Now notice that because this is a parallelogram, then that is 16 and that is 12 and that is 72 then, because it's opposite angle in a parallelogram. So I've actually got two congruent triangles here, aren't there? They're both exactly the same shape and size. So if I can find the area of one of these triangles and double it, I'll get the area of the parallelogram. Now I do have a formula involving two sides of a triangle in the included angle. It's that trigonometry version of it. So the area of a triangle is going to be, well, it's half AB sine C, isn't it? So half of the two sides, 12 and 16, times the sine of the included angle, sine 72. So what's that? Reaching for the trusty calculator. Half times 12 times 16 times the sine of 72. It's giving me 91.3. 91.3. But then my area of the parallelogram is going to be my area of the triangle times 2, which is 91.3 times 2. So let's just double that up. Times 2 is 182.6. So that's my answer, 182.6 centimeters squared. Question 18a. I've got a Venn diagram here with an area shaded on it, and we're asked which of these represents the shaded region. Is it A? Is it B dash? Is it A intersect B dash? Or is it A union B dash? Okay, now this dash means not, doesn't it? So B dash is not in B. So clearly the area is inside A, but it's not all of A. And clearly the area is outside B, but it's not all the area outside B. It's going to be one of these two at the end, isn't it? It's going to be either A intersect not in B or A union not in B. Now another way of reading these intersections and unions is using the words and or. A intersect is the same thing as and, really. You can think of intersect as and. So is it in the set A and not in B? Oops. Or is it union, which we can read as or? Is it in A or in the or not in B? Well, I think it is this one. It's in A and it's not in B. Because if it was in A or not in B, it would also be this area around the edge here. That would be A or not in B. So not that one. It's A and not in B. In question 18b, I've been given another region on the same diagram, and again I need to find the correct set notation to use here. Now remember what I was saying earlier, that union is the same thing as or, and intersect is the same thing as and. Maybe that helps. So let's see if we can decode what some of these things that I've written down here. What is A union B? Well, A union B is the intersect of... No, it isn't. A union B is everything inside A or everything inside B. So then the not that then is going to be everything not in that intersect. It's going to be everything on the outside. So I think that's the one we want, isn't it? It's that one there. Let's just double check. A intersect B is just a bit in the middle, and then if I flip that round, that's going to give me everything on the outside plus that bit plus that bit. So the only bit that's left unshaded is a little teeny tiny bit in the middle. So it's not that one. Not in A intersect B. So not in A and in B. So that is just going to be that bit there, isn't it? Not in A intersect with B. And then this last region, not in A union, not in B, is the same as the one we had earlier. So not in A union, so I can shade all that and I can shade all that, and it just leaves me that little bit in the middle again. So yeah, it's definitely that first one there, A union B dash. Question 19, the length of a rectangle is 5 times the width, and we're told that the area of the rectangle is 1620. So that is 1620. We know that the length is 5 times the width, but we don't know what the width is. Let's call the width x, and therefore the length is going to be 5 times that. That's going to be 5x. So work out the width of the rectangle. Okay, so the area of a triangle, of a rectangle, is length times width. So using our diagram, 1620, the given area is our length, which is x, multiplied by our width. So 5x times our width, which is x, which is 5x squared altogether. So I've got a linear, quadratic equation in x here then, haven't I? So dividing both sides by 5, or cross multiplying that 5, I'm going to get x squared is equal to 1620 divided by 5, which my calculator tells me is 1620 divided by 5, 324. So x squared is 324. So then if I square root that, I get 18. So x then, now remember it's plus or minus 18 though, but in this case the negative value is not possible. So it is just a positive solution there. Then the width then is the shortest one. So it's going to be 18 centimeters. Question 20. A stone is thrown upwards with a speed of v meters per second. The stone reaches a maximum height of h meters. H is directly proportional to v squared, where v is, and when v is 10, h is 5. Work out the maximum height reached when v is 24. Okay, so we've been given this. H is directly proportional to v squared. So I can write that down mathematically as h directly proportional to little fishy v squared. So h little fishy v squared. Now then I can replace that proportionality symbol with equals k. So h equals k lots of v squared, where k is some constant that I can find straight away. Normally with these, well, always with these really, they give you a pair of values that go together. That pair of values is specifically for evaluating your value of the constant. So let's sub those in. So when v is 10, h is 5. So subbing those in, 5 equals k lots of 10 squared. So you can see the only thing we don't know there is k. So 5 equals 100. K, giving me k is 5 over 100, or 0.05. So that's my value of k. So once I know what k is, and I've got the complete equation that links h and v together, so then h is going to be 0.05 v squared. Now students often mix up what is a constant and what is a variable in these sorts of equations. H and v are both variables and they can take multiple values within the question. K is a constant and it has only one value, and once you find it and replace it, you don't have to think about k ever again. So I've got my complete equation in h and v, which I can now use for the remainder of the question. So the last part of the question then says work out the maximum height reached when v is 24. So we don't have to work out the maximum height. All we've got to do is sub in the value v is equal to 24 into this equation and work out what the answer is. So that's what we're going to do. When v equals 24, then h is going to be 0.05 times 24 squared. Trusty calculator time. 24 squared times 0.05 gives me a height of 28.8 meters. So that's my final answer, 28.8. Question 21a. Mira is using a graphical method to solve 2x squared minus 3x equals 0. So she's drawing the graph of 2x squared and a straight line graph on the same grid. Here is the graph of 2x squared. And we need to complete her method to solve 2x squared minus 3x equals 0. Okay. So we've got the graph y equals 2x squared already drawn, and we know that we want to find the solution when 2x squared minus 3x is equal to 0. In other words, we need to find when 2x squared is equal to, well, just moving that over there, look. I need to find out when 2x squared is equal to 3x. Now I've already got the line y is equal to 2x squared drawn, so if I draw the line y is equal to 3x, then I can find where those two lines are both the same at the points of intersection. So the graph y equals 3x, very simple graph to draw. You could draw a table of values, or y equals 3x, when x is 0, y is 0, it goes through that point. When x is 1, y is 3, goes through that point. When x is 2, y is going to be 6. It's going to be there, there, and there. So just taking a ruler, carefully drawing a line through those points. So then the points of intersection then have got to be the solutions to the equation. So there's one solution there at the origin, and there is another solution here. What point is that? That is the value, well, it's at 1.5 and 4.5, I would say. So what are the two solutions? It's going to be when x is 0 is the first solution, and when x is, what was it, 1.5. 1.5 is the second solution. 21b. Levi is solving 2x squared plus 5x equals 0. he uses this method. 2x squared plus 5x equals 0. Subtract 5x from both sides. 2x squared equals minus 5x. Divide both sides by x, gives me 2x is equal to minus 5, and then divides both sides by 2, which gives me x equals minus 2.5. Now, on the surface, it looks like it's a solid method, but you should never really divide through by an unknown, because you can lose values. At this point here, where he divides both sides by x, he ends up losing values. He loses a solution of x. So he's only got one answer, isn't he? And this is a quadratic. You'd normally expect two solutions to a quadratic equation. So evaluate his answer. I'm going to say he has lost a solution. What really you should have done here is factorize out the x. So better to factorize. So you get 2x squared plus 5x equals 0. So factorizing out the x, going to get 2x plus 5 is equal to 0. So then here I've got x is equal to 0, which is my first solution, and I've got my x equals minus 5 over 2, which is the same solution as, what's his name? Levy found. Okay. Question 22. The cross-section of an earring is a semicircle centered C, radius 25 millimeters. The earring is black and white. The shaded area is black. Okay, so that bit in the middle is not a hole, it's a white bit. So the sector BCD is white and has a radius of 12 millimeters. There's the sector. So that's all the information on that page. Is more than 20% of the semicircle white? You must show your working. Okay, so therefore we're going to have to work out the two different areas and then see if one is 20% of the other. Okay, so where should we start? Should we start with the... Well, let's start with the sector, because we have to take the sector away from the other bit, don't we? So let's start with the sector. The sector has a radius of 12 and an angle at the center of 150. So the area of the sector then of the sector is equal to 150 360ths of the area of a circle, which is pi r squared, where r is the radius, which was 12. So it's that, isn't it? So the area of the sector then is going to be 150 divided by 360 times 12. I'm going to leave it in terms of pi for now, because they both have pi in it. And I want to compare them, and the pi's will drop out. So that is 60 pi. I'll keep the numbers easier if I do it this way. So the area of the white part then is going to be 60 pi. So what about the semicircle then? The area of the semicircle is going to be 1/2 of pi r squared then, isn't it? So what is the radius of that? 25. So it's going to be 1/2 of pi times 25 squared. So 25 squared, 625 divided by 2, 312.5. I'm just going to leave it as 625 pi over 2 for now. Okay. So the percentage that's white then is going to be 60 pi divided by 625 pi over 2. So dividing through by a fraction is the same as flipping that fraction over and multiplying. So that's going to be the same as 60 pi times 2 over 625 pi. So that's where the pi's are going to cancel out. So then I've got 60 times 2 divided by 625. 60 times 2 divided by 625 equals 0.192. So as a percentage, that's 19.2%. So the question was, is it more than 20%, or is more than 20% the semicircle white? And we found it's 19.2, so the answer is no. It's less than 20%. Question 23. Here is some information about a tennis club. Now, the graph is entitled Members of a Tennis Club, and along the bottom we've got ages, and at the side we have frequency density. So this tells me it is not a bar chart, it is a histogram. So in a histogram, it's the area of the bars that is proportional to the frequency and not the height. So what we've got underneath, there are 30 members with an age less than 20. So then the area of this bar here then should be those 30 members. And we're told there are 12 members between 65 and 80. Now, interestingly, that's that bit up there, and it's not been drawn on. So I suppose we have to add that bar in. And then there are no members beyond 80. Okay. So what do we need to do? Well, first off, we need to work out what one square is worth here, I think. So we can work out how tall to draw our bar for the missing bar for the 12 members who are between 65 and 80 years old. So let's have a look at this bar here then. So I've got 30 is the area. Now the baseline, or the baseline of that rectangle, is 20. So then the height is what you have to multiply 20 by to get 30. So the height of this bar is going to be, well, 20 times what is 30? Well, it's going to be 20 times 1.5 is 30, isn't it? So that bar has a height of 1.5, which means on this scale, then let's just tidy that up. Each of these little increments then is going to be 0.1, aren't they then? So that's 0.5, 0.5, 1, 1.5, 2, 2.5, and so on. Okay, that's going to help a bit. So we know how many, so what the frequency density is up there. So there are 12 members with a height of between 65 and 80. So frequency density equals frequency divided by class width. So in this case, for the 12 members, the frequency is 12. The class width is from 65 to 80, that's 15. So then the frequency density then is going to be 12 divided by 15, which is unhelpfully 0.8. Doesn't fit on our scale very nicely, does it? Luckily there are smaller blocks within there. So we've got to draw a bar of height 0.8. So 1 was here. So each one of these little squares has got to be 0.1 then. So get my ruler out. At a height of 0.8 and a width of 15. So it's going to look, oops, it's going to look like that, and then down to 80, and that represents 12 people. Okay, so that's that one done. Okay, now the last part of the question says work out the total number of members of the club. Okay, so coming back to our graph, remember it's the areas that are proportional to the frequencies in a histogram. So we already know that there's 30 in that first bar and 12 in the last bar. We need to work out the frequencies of the three middle bars. Now remember, frequency density is equal to, remember it's the area of the bar then that you need. So this first tall long bar, let's just complete our scale. 3, 3.5, 4, 4.5. So it's got a height of 4.5 and a width of 10. 4.5 times 10. 4.5 times 10, that's 45. The next bar along has also got a width of 10 and it's got a height of 3.5. So 3.5 times 10 is 35. The next bar along, the fat one, is got a height of 2 and a width of 10, 20, 25. 2 times 25, which is 50. Okay, so then the total number in the club are going to be those values added together then. So the 30, the 45, that's not 35, that's 36. Oops. Let's just change that. Good spot, Tony. That's equal to 36. So 30, 45, 36, 50, and 12. So then the total, 30 plus 45 plus 36 plus 50 plus 12, giving me 30 plus 45 plus 36 plus 50 plus 12. That comes to 173. So 173 members of the club. Question 24. Beth ran a 200-meter race. Here is a graph of the first 8 seconds of her race. She completed the race at a constant speed of 9 meters per second. Okay, so we've got a speed time graph here. And we're told underneath that Amy completed the race in 27 seconds. Did Beth finish before Amy? You must show your working. Okay, so we were told that Beth continues the race at 9 meters per second. So I can get a ruler out and draw the rest of her speed time graph. So it's just going to flatline after there. So the rest of the graph is going to be a flat line until she finishes. I'm not quite sure when she finishes. Maybe we should work that out. So she's got to cover 200 meters. Now we know that the area is the distance under the graph. So if I just draw a line there and work out the area that she covered in the first part of the course where she was accelerating. So that is a triangle. So the area under the graph is going to be a triangle of base 8 and height 9. So half base times height is going to be a half of 8 times 9. So 4 9s are 36. So she covered 36 meters in that first part of the graph where she was accelerating, which means that the other part of the graph, which is going to be a rectangle, has an area of 200 minus that 36 meters, which is 164. So it's going to have an area of 164. Now we already know that the height of the rectangle is going to have to be 9. So if I divide 164 by 9, I'll know the length of that rectangle. 164 divided by 9 is 18.2. So it's going to take her another 18.2 seconds to finish. So if she's at 8 seconds, then she's going to finish 18.2 seconds beyond that, which is at 26.2. So completing the graph unnecessarily because I've already got the answer, haven't I? But let's just finish it off for completion's sake. So 164 divided by 9 tells me that was 16.2, so she must have finished the race. So it was 18.2, wasn't it? So she must have finished the race at 26.2 seconds. So Beth finishes at 26.2 seconds. So did she beat Amy? Of course she did. She was 0.8 seconds quicker. So she does finish before Amy. Go Beth. Question 25. The dimensions of a rectangular floor are to the nearest 0.1 meters, 2.6 meters and 6.4 meters. Okay, so before we go any further, this thing here is telling me what type of question this is. This is a limits of accuracy question. So we're interested in the maximum minimum possible values, I think, for this question. Anyway, let's read on and find out the rest. A force of 345 newtons is applied to the floor. The force is to the nearest 5 newtons. So pressure equals force divided by area. Work out the upper bound of the pressure. Give your answer to 4 significant figures. You must show your working. Okay. So let's take our lengths and widths of our rectangular floor first off. It's to the nearest it's the nearest 0.1 meters. So 2.6 meters, then the width. If I've got 2.6 on the number line, then 0.1 more than that would be 2.7. 0.1 below that would be 2.5. And then the values that are closer then to 2.6 are going to round to 2.6. Now they're going to be the values that are halfway between 2.5 and 2.6. So 2.55 is the lower bound and 2.65 is the upper bound. Okay, if I have a look at the length, do the same thing. 6.4 in the middle, one more would be 6.5, one less would be 6.3. So then the values that are going to round to 6.4 are going to be 6.35 is the lower bound and 6.45 is the upper bound. So then we're told a force of 345 newtons is applied to the floor, and that force is given to the nearest 5 units. So again, drawing 3, 4, 5. 5 units above it would be 350. 5 units below it would be 340. And the ones that would round to 345 are the ones that are going to be halfway between those values. So halfway between 340 and 345 is 342.5, that's the lower bound, and 347.5 for the upper bound. Okay, they're the ones that round to 345. Okay, so now I've got all my maximum minimum possible values. I can then go on and consider which ones I'm going to have to use. So we're told that pressure equals force divided by area. Work out the upper bound of this pressure. What's the largest possible pressure I can get from those values? Okay, so pressure then, am I going to use the largest possible force or the smallest possible force to get the largest possible pressure? Well, I think I need the biggest possible number on the top of this fraction if I'm going to get the largest possible pressure. So I'm going to take the upper bound of my force, 347.5, and I need to divide that by the area. So then the area, am I going to take the smallest possible area or the largest possible area to make the largest possible pressure? I think I need to, if you're going to divide, you want to divide by the smallest possible value to give you your largest possible value. So what's my smallest possible area I can get? that would be taking the lower bounds of my two sides of my rectangle and multiplying them together. That would give me my lowest possible area then. So that's going to be 2.55 times 6.35. Now if you're getting confused or can't figure this out, you can just do the calculations multiple times with the various values and seeing which one is the biggest and the smallest. It might be worth doing that anyway if you've got a bit of spare time towards the end of the exam. It's a good way of checking your answer. So 347.5 divided by 2.55 divided by 6.35. That comes out to be 21.46. To four significant figures. 21.46. Interesting that they asked for four significant figures there. It's quite unusual. Okay, so that's my answer, 21.46. Question 26. ABCDE is a pentagon. Show that BCDE is a parallelogram. Now it doesn't look like a parallelogram in the diagram, but it's not drawn accurately. Now what are the properties of parallelogram? Parallelogram is made up of two pairs of equal and parallel lines. In other words, this line here has got to be equal in length and parallel to this line here, and this line here, CD, has got to be equal in length and parallel to this one. So to show that this shape is a parallelogram, all we got to do then is show that this vector here is going to be the same as this one, and whatever the vector is here has got to be the same as this one here. Okay, so if I can show that those two pairs of vectors are equal, then I've shown that it's a parallelogram. Okay, so let's start with DE because I've been given that one. I've been given DE. So DE should be identical to CB. So here's C and there's B. Now can I get from C to B along routes that I know about? I can go along here, and I can go along here, and I can go along here. Okay, now they're going against the arrows, but that doesn't matter. Let's find vector C to B. Right, C to B is C to E plus E to A plus A to B. That's the root. Now using the vectors A and B that have been given, C to E is against that arrow, so it's going to be the opposite of that, isn't it? It's going to be minus. So it's going to be minus B minus 2A. I'm going against that arrow as well, so E to A is minus 2B. Minus 2B. And A to B, again against the arrow, so that's going to be minus A. Let's just deal with that bracket. Minus B, minus minus is plus, so that's plus 2A minus 2B minus A. So right, we can start collecting like terms together then. So what have I got? I've got positive 2A and a minus A, so that's going to give me A, and I've got a minus B and a minus 2B, which gives me minus 3B. So my vector C to B is the vector A minus 3B. But hold on a minute, that's the same as the vector D to E, isn't it? A minus 3B. So I can say that is the same as D to E. Okay, so that's the first part done. I've shown that the green lines are equal in length and parallel. Now I need to do the same thing with the yellow lines. So let's take the vector BE to start with, work out what that is. So B to E, well, that's just along B to A and then A to E, isn't it? Yeah. B to A and then a to e, which is, this is a little easy, this bit is a bit easier, isn't it? A plus 2b. A plus 2b, so that one's already done. And we need to compare that with the other one, c to d. What's c to d? Now c to d, I can get along that purple line and then down the green one. So from c to e and then from e to d. C to e and then e to d. So c to e is b minus 2a. Oh, it's going against the arrow, isn't it? So it's minus that. Minus b minus 2a. So minus b minus 2a. And then again, I'm going against the arrow of that one. So it's minus a minus 3b. Minus a minus 3b. Okay, and then we're dealing with all those negative signs. Minus b is just minus b. Minus negative 2a, that's plus 2a. Minus a is minus a. And minus 3b is plus 3b. Okay, now again, collecting up like terms. I've got minus b and a positive 3a. And I've got a positive 2a and then a minus a. So that gives me an a plus 2b, which you'll notice is the same as that one. So again, I can say, well, that is the same thing as b to e. Okay, so just to summarize that, I can say that cb equals de. So c to b is equal to d to e, and b to e is equal to c to d. Therefore, b, c, d, e is a parallelogram. Okay, cool. Question 27, a nice bit of algebra to finish off with. Solve x over 4 minus 2x plus x plus 2 is equal to 1. Give your solutions to 2 decimal places. You must show you're working. Okay, so just this bit here is telling me something. Normally that means that we're having to do some sort of calculation with surds. I would imagine that means we've got a quadratic later on that we need to solve and we can't factorize it. So anyway, let's just see what we can do. Okay, let's take the left hand side first and try and put it over one fraction rather than 2. So if I make the denominator 4 lots of x plus 2, I can do that by kind of taking this value here and multiplying it by this one. So x plus 2 on the top, and then subtracting this times by this, isn't it? 4 lots of 2x. If you get confused with this, try and remember what you would do with two numbers. So if I got 1 over 2 minus 3 over 4, how could I put those over one fractions? And you can normally work these out for yourself. Anyway, so let's continue. So that's equal to 1. So just, I think what I can then do is cross multiply this over here, and then I can deal with that left hand side as well in the same line. So that's going to give me x squared plus 2x minus 8x on the left, and I'm going to move the 4x plus 2 over. I'm going to multiply it out at the same time, so it's going to give me 4x plus 8. Okay, right, then I'm going to collect everything on one side, so I'm going to move these two things back over. So I'm going to get x squared, So I've got 2x and I've got minus 4x coming over, and I've got another minus 8x there. So 2x minus 8x is minus 6x. Take away another 4x is minus 10x. And I've got minus 8 coming over as well, and that's all equal to 0. So now I've got my quadratic in x squared. Now, I could attempt to factorize it, but as I said earlier, as it's asking me to give my solutions to 2 decimal places, I suspect it's not going to factorize. And if you think about factor pairs of 8, 1 and 8, 2 and 4, you're not going to make 10 out of those pairs, so it's not going to factorize. So we are going to have to use the formula here. Can you remember what the formula is? Formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. It's not that bad really. Right, so what's a, b and c? That's my value of a there, that's a. This is b, this is c, isn't it? So sub in those values carefully in. Minus b is minus minus 10, which is plus 10. 10 plus or minus the square root of minus 10 all squared minus 4 lots of a, which is 1, times c, which is minus 8, all divided by 2 lots of 1. Okay, so let's see if we can simplify that a little bit. So that's 10 plus or minus, right, I've got minus 10 all squared, which is 100, positive 100. I've got a negative times a positive times a negative, which is going to give me positive. 4 times 1 is 4 times 8 is 32. So 100 plus 32 all square rooted over 2, which is 10 plus or minus the root of 132 divided by 2. Okay, so time to reach for the calculator. 10 plus 132, 10 plus the root of 132 divided by 2 is 10.74. So x is equal to 10.74, or x is equal to what I'd get if I take that away. So 10 minus the square root of 132 equals, divided by 2 equals, what's that then? Minus 0.74. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.